Hello, welcome to Algebra 2. We're in Chapter 7, Section 4. This is page 2 of the notes. And here we have example 2 where we have to evaluate logarithms. On the last page, they were already equations because you knew the answer. You were mostly practicing changing the form of the equation. And there's some fun to do there. Here, however, they're not equations. You don't know exactly what the value is, and you're meant to figure it out. So for part A, we have log base 3 of 81. And you might already see the game here, but if you look down at the solution, they try to walk you through it here. It says 3 to what power gives you 81? And normally most people don't know that immediately, but if you think for a minute, you're like, oh yeah, 3 to the 4th power is 81. So log base 3 of 81 is 4. Boom, done. Let's look at B. Log base 4 of 0.25. Now remember, 0.25 is 1/4. That just might help you out. In fact, let me rewrite that a little bit better. One-fourth fraction will help you in this situation. 4 to what power gives you, and they say 0.25, I recommend you think of it as 1/4. And then hopefully you're like, wait, oh yeah, because it's upside down, so it's to the -1. So log base 4 of 0.25 is -1. Boom. All right, part C. Log base 1/4 of 256. Oy, oy, oy. All right, 256, just, for fun for everybody, that's the same as, just, this is 4 to the 4th power. That might help you out here. Otherwise, you might need to do some guess and check because it's actually -4. Because you do the negative sign to turn it upside down to make it a normal 4 you're multiplying by, and then it's also to the 4th power to get to 256. So log base 1/4 of 256 is -4. And then finally, part D. Log base 49 of 7. The question is, what power do you take 49 to get to 7? And the answer is 1/2 because it's a square root, and square roots are fraction exponents. So log base 49 of 7 is 1/2. That's all for example 2. Now, we got a checkpoint. All right, so we're going to try this like last time. I'm going to pause for a few seconds so you can pause the video. Try the checkpoint on your own, then come back, and I'll show you what the answers are. So please go ahead and pause the video now and try it yourself. All right, so for number 3, the first one on this checkpoint, you have to ask yourself, 1/3 to the what power equals 9? And that magic number is -2. So the answer for number 3 is -2. I'll come back in just a second with answer number 4. And here for number 4, you have to ask yourself, 16 to the what power is 4? And so and that's 1/2 because square root of 16 to get to 4. So the answer is 1/2. Now let's look at example 3. Here they use some properties and they pull a couple quick tricks on you. So first of all, if you look at number A, it says 10 to the log 6.7. Now, first of all, you may very well be frustrated that this log thing is already in an exponent. I totally understand. We'll deal with that in a second. But first, they did another even slightly dirtier trick to you. It says log 6.7, and if you look at it again, you may wonder, where's the base? Because all the other logs have had little number bases underneath them. So if there's no base in a log, it just says log, it means base 10. If there's no base in the log, it just says log, then it definitely definitely means base 10. So we gotta make sure we write a little 10 in there. Ah, there it is. Okay, so 10 to the log base 10 of 6.7. Now, to solve A here, they have this little property. This is a thing that's worth writing down. Of course, it's more important to practice it, but somewhere where you write things down that you might memorize, you might write this down, a couple examples, because this is 10 to the log base 10 of 6.7, and it's kind of like the log and the base, they cancel each other out, and that's basically what's going on because they're inverse functions, actually. So it's the base of the exponent is the base of the log. You can kind of sort of in your mind cross them out, and the answer is 6.7. Boom. Now, I said kind of sort of because the 6.7 was in the exponent, whereas now it's actually your normal number answer. Don't sweat it too much. If the base matches the base of the logarithm and they're inside each other, just do away with them and look at the number you're looking at. All right, so for part B, though, we have log base 2 of 16 to the x. And you might think, oh, okay, well, that x is annoying. But the 16, ay, ay, ay. Okay, here's the deal. First of all, we got to change 16 as a power with base 2. So I'm going to rewrite this for you. This is a trick you're going to need to get used to. This has nothing to do with the x in the problem. So it's log base 2. Instead of 16, it's 2 to the 4th to the x, because 16 is 2 to the 4th. Okay. Now we're going to use our property of 2 to the 4th to the x. That's 2 to the 4x. Power of power means you multiply the exponent. This should be old hat for you. The fact that it's inside this log doesn't have anything to do with anything. So you just kind of rewrite the log base 2. Don't sweat it. Now, here we go. Because the log matches, because the base of the log matches the base of the exponential piece, and they're inside each other, you can essentially cross them out and write, boom, 4x is your answer. Now, A and B are different versions of the same idea. If the base of the exponential function matches the base of the logarithm, and if one of them is inside of the other, then you can cancel them out and just deal with the exponent that's left. That's all for page 2. It was quite a doozy, but thank you for watching.